Welcome back, my friends. As you probably know, SQL databases are everywhere. And if you're coming from R and are so used to the smooth dplyr workflow to wrangle data, then it can feel really frustrating to having to work with SQL and trying to figure out how to get this raw SQL code into your code base as string. This can be really frustrating, but thankfully it doesn't have to be so, because you can use the dbplyr extension for dplyr to just use mostly your regular workflow to interact with SQL databases. So in today's video, I'll show you 10 really common SQL operations and how to do them with dplyr/dbplyr. And with that said, let's dive in. For this video, I've prepared a little dummy database for you that is stored in a file that I'm going to connect to. You can see in my Explorer that here inside of this directory there is the SQLite file, which contains all of my database tables. And if I execute this part here, then I am connected to my database, and now I can run queries against it. And to show you how dbplyr works, let me just show you a simple query that you can understand even if you don't know how SQL works. So here I'm getting two columns, title and price, from a table that is called books, which is inside of my database. And if I execute this, I see that I get this small table here. If I wanted to get all columns, just so that you get a feeling for this table, you could put in a star, and then you'd see that I have all kinds of IDs and information like the published year inside of my database, or rather inside of table of my database. So here I only want to grab these specific columns, and if we want to use dbplyr, then we first have to sort of connect to the table. And this works via the TBL function, which takes in the connection as an argument and then the name of the database table. So if you have a look at this, you'll see that it prints like a tibble, but it comes with additional information like the source and the database. And this is something we can store in a variable. So now we know that inside of the books variable, we have our table in there. And with that, we can just take our table and pass it to the select function from dplyr and select the columns that we want to pick. So here we see that we get a table, but we also see that we don't get an information about how many rows we actually extracted. The thing that you have to keep in mind is that here it is only a preview of the first couple of rows of whatever you selected. If you want to collect the full result, then you'll have to use the collect function to collect stuff. Here we don't get any more rows than we had before, because this database is small, but in an example it isn't as contrived as what I'm showing you here. You'd get way more rows, even if this preview just shows you a handful of rows. And also notice now that this is a regular table and not a database table. So the moment you collect stuff, then you have it inside of your R session basically. So that was easy. Let's go for the more difficult example. Not too difficult though. Let's add a where statement to our SQL column to grab only the rows where the price column is larger than 20. So let's take our code from before and let's not collect stuff here. If we execute only this regular SQL code, then we see that we get these two rows here. And just like you normally would in dplyr, you can work with these database tables in the same way. You can just use filter and say price is larger than 20. And if you execute this, you'll see that you only get these two rows here. And again, this is the database preview. If you want to get the actual full data, you'll have to collect stuff, and then you get this full data set as a table. But this is nothing new here, so let me show you something else that is new. Namely, we can actually see the query. You see, you can use the show query function to take a look at the SQL query that this dbplyr code generates for you, so that when in doubt, you can check that this stuff here actually corresponds to the query we were looking for. Sweet, so now you know that you can also check the query if you're unsure whether dbplyr translates what you specified to the correct SQL query. So that's a neat thing to know. Next, let us do another typical thing, and that is arranging rows by a specific value. Here in this case, we could get the book titles arranged by price. In SQL, this is done by order by, and if we want to sort things descendingly, we'll have to use this descending tag. And as you probably know, in dplyr it works pretty much the same. You can just not filter here, because here in this query we don't actually filter. What you want to do is you want to arrange the rows, and if you want to arrange stuff descendingly, you have to use the descending function, and in there you can stick in the price. And now you see that you get another preview, and once again, when you collect the stuff, then you see that you have the exact same result as you had before. And if you wanted to, you could also check the query to make really sure that this is actually the thing you were looking for. Fantastic. Let's do another very common query, and that is using joins. Let's investigate what the SQL query does here. It selects from a table B the column title, and it selects from table A the column name under the name author, where it says that books corresponds to B, authors corresponds to table A, and these two tables are joined via the author ID. Honestly, this takes a bit of work to parse because here you're already using abbreviations before you know what the abbreviation stands for. That's something that might feel odd to you if you haven't worked with SQL a lot before. And the first thing that we notice here is that we need another table authors. So let's throw this in here. The idea is once again to use the TBL function to get this authors table and save it into a variable that we call authors. And in there you see that you have some author IDs, names, and countries. And if you recall, inside of the books table, we had author IDs as well. So we can join these two tables via their common column. And the way this works is that you grab the first table, in this case the books table. So you grab that variable and you pass it to the inner join function from dbplyr as if this were just regular tables, and you want to join it with the authors table by the author ID that is present in both tables. If they had different column names, then you would specify these according to what would be in the SQL query, but here both tables have the same author ID column. So technically you could also just write by author ID and not need to use this kind of syntax here. But it's good to be explicit here. So if this table here had author ID 2, here we'd also stick an author ID. I think you get the idea. But here we don't need that. Instead, what we need to do is to still select the things that we want to grab. We said we want to grab the title, all right, and we also want to grab the name, but we want to grab it under the name author. So let's set author equal to name, and then we see here that we get an error because I copied this B dot as well. Of course, we only want to get the title. So now if we do that, we see that we get another preview here, and once we collect this stuff, we see that we have a regular table again with our data joined together. Sweet, so now we've covered one common thing, that is joins. Let's talk about aggregations and specifically grouped aggregations. For that, I brought a tiny bit longer SQL query to practice this on. So once again, we're using the table books, but we're also joining on a table genre. So we'll have to get this table as well. So let's write into genre. Let's use the TBL function, use our connection to the database, and stick in there this genre table. And what we do there is that for every genre, we group things together. We want to count how many books there are. That's basically it. And in order for us to do this, we first have to join books and genre together. And then we also want to make sure that the results are ordered by the number of total books. And when the numbers match, we also want to make sure that the book names are sorted in alphabetical order. And I said book names, but I really meant genre names here. So let's have a look at this new table. Really, it's pretty simple. It has an ID and it has a name. And our first task will be to join this together with books. So let's take the books and let's inner join them with genre. Can do this by this genre ID column, because inside of books, we also have this ID present. And then if we want to summarize stuff by group, we group things together using group by, and we group this by genre. That is the name column. And then we do the actual summary by using summarize. And then we want to say total books is equal to the number of books. And as we execute that, we see that we get this table here. We have 3 fantasy books, 2 literary fiction, and 1 science fiction book. And we wanted to arrange stuff. Here we wanted to make sure that we sort descendingly by total total books and ascendingly by genre name. So really nothing changed there because the order was already fine. And finally, we can collect stuff. So at this point, it is a regular tibble. And now you might wonder, okay, why do I collect at the end? Why don't I just, after the summary, collect stuff and then do the arrangement? Or why don't I do that with some other stuff? Why don't I grab all of the data and then do just regular dplyr things instead of using dbplyr here with SQL in the middle of all of this? And the reason for that is pretty simple. If you execute all of this stuff before collecting, then you will have offloaded all the heavy calculations to the database, which usually is optimized for running these kind of things. And there often is a lot of computation power behind this. This is actually a trick that I covered in my last video on how to optimize Shiny apps, where I show you that if you want to make your Shiny apps faster, it's nice when you can offshoot some of the calculations to some other computation power. And in this case, if you were to collect at the end and let the database worry about summarizing and grouping, then things will be faster for your app. And in general, I believe it's often a good idea to throw these kind of things to the place where the computation power is optimized for this. So that's my rule of thumb here. Next, let us do another typical SQL thing, and that is inserting things into already existing tables. For that, I've brought you another table called customers, and into this customers table, we want to insert into name and email, into these two columns, the name Alice Johnson, using the email alice2@example.com. And as you probably guess, we first want to save this customers table using this tbl function via our connection where we stick in the customer table name. So if we look at our table, we see here that we have these customers here. And now if you want to insert an additional user like Alice Johnson with alice2@example.com, you see here this user is already present because I've already ran this code before. So let's just stick in some other name. And the funny thing is, if you ask ChatGPT if this is possible with dbplyr, then it might just tell you, no, you can't do that. But the thing is, it's actually possible. What you can do is to take your customers table and use one of the many rows functions. There's rows append, rows delete, and so on. These work nicely with tables. And here we want to add a new row, so we want to append stuff. Actually, we don't want to append stuff, we want to insert stuff. But as you can see here, they do exactly the same thing, but this row append ignores keys, like primary keys that are the identifiers for specific rows. But here let's stick to rows insert because then it matches closely to what we do here. So we want to insert a specific tibble, so we have to create one. Let's create a tibble using the names that we find here. Let's insert the name Alice Johnson 3. I know, very creative. And as an email, we'll use alice3@example.de just to show off that there are also some other domains other than .com. And now if I try to execute this, we'll see that, okay, there seems to be some error. It says conflict error isn't supported in database backends. It must be ignored instead. And if we look into this rows insert function, you see that there's always a conflict argument and it can be set to error or ignore. So if we set to conflict and set it to ignore, then we see that we get yet another error, but a different one. Namely, it tells us that this table and this tibble are not of the same type. It tells us that customers, it is database connection. This is why it says source table customers from some database. And this stuff here is a tibble. These are two separate things. And dplyr is trying to warn you, hey, you're trying to stick together two things that are slightly different. What's going on there? But it also tells you if you want to copy the Y table, the one that is in rows insert, into the X table, the one that comes from the outside, then you just have to set copy to true. But this is possibly slow because you're copying things. So be aware, this is the trade-off you're making. So this is why there is a warning instead. But if you set copy to true, then you see that, okay, things are now inserted. There is Alice Johnson 3 now in here, but you also see that there is no customer ID. And also what you can see, if you you check the customer table, you see that your database connection, it doesn't reflect your change. And the reason why is because in rows insert, if you want to make the changes actually stick, there is the argument called in place that says should X, so the original table, should it be modified in place? And it tells us this is only relevant for mutable backends like databases and data tables. So let's stick this in here and say in place is set to true. And now things work fine. We don't get a result back, but instead, if we look into our customers table, we see that Alice Johnson 3 is in our database now. So that's how you can insert new things into tables using dbplyr. Of course, you might wonder, okay, it's kind of hard to learn these silly little things when the command is this short and it's really easy. The point here is that if you have a lot of data, then this stuff here might actually be more handy than trying to stick things into these SQL commands. So it is worth learning this dbplyr syntax. Next, let us talk about updates. A typical thing that you will do with databases is that you update some rows. For example, here we update the books table to set the price column to a rounded version of a reduced price, but we only do this for the books where the published year was before 2000. So let's have a look at our books table right now. And here we see the books that were before the year 2000 are these here, and they cost this amount of money. And if I were to execute this stuff here, you see that 3 rows were updated, namely the one that we've just seen. And if we look into the books table now, we see that this has updated. The price is different for them now. Here are the originals, here are the new ones. So let's try to do the exact same operation, but with dbplyr. And here is where we can combine a couple of things that we've learned before. We can just filter a table using the filter function like before. So we're just using published year is before 2000, and then we select only the price and the book ID column. We're getting the book ID column here to have this as a reference later of what rows should be updated. Namely, these books that are before year 2000 have the book IDs 2, 3, and 4, and these are exactly the ones that we have here. And now we can modify these things using mutate, and there we can say, okay, the price is the rounded price times 0.9, and we round to 2 decimals, and then we'd see that this is the price. Now remember, this is a database table and the changes don't necessarily stick. If we look into the books table, we still see the original prices here. This here is just some temporary version of what you're trying to do, but it is still a table that we can save into a variable. Let's call it table modified prices before 2000. So now we can always check out this table and we always see these modified prices here. And now we can take our original books table and use another one of these rows function, namely the rows date function, and it needs to be combined with another data frame or data frame extension like a tibble or database connection. So that's why I didn't have to collect stuff here. So I can stick this in here, and then I have to specify that I want to join these two by the book ID name to make sure that the rows that are supposed to be updated are uniquely identified by this ID. And if we do that, we once again see the same things like, okay, unmatched isn't supported, it must be ignored. So all right, let's do unmatched and set it to ignore. And now we see that things changed. And here we see our modified prices. But if we look into the books table for these rows, we still see the original prices. Once again, if we want to make the changes stick, we have to use the in place argument and set it to true. So now if we update this, it takes a bit, but then if we check out the books table, we see that the prices were actually updated. And another thing you could try to do is to use the show query function here again to check out what kind of query we get. But in this case, this doesn't really help us that much. But if we don't use in place, then we see our full SQL query here. Actually, it's interesting. We've seen some part of the SQL query. I think positron just didn't scroll down. It actually didn't make a mistake. It scrolled regularly, but this query is just so long. What I wanted to mention here is that this round function that we use here inside of of our code was properly translated to the stuff that SQL also understands. But the nice thing here is that in R we have way more options to calculate some very elaborate thing using R's magic, and we can leverage this to update our database tables, but then this SQL translation might not work properly. So this is why in some cases you might actually have to collect stuff first, and at this point this is just a regular tibble, and from there on you can use mutate with all the R magic that you can think of, and then you have once again a regular table that you can use to update the original SQL table. So this is also a valid strategy where you can leverage also R strengths to modify in ways that are not possible in raw SQL. So this was tricky. Let's do an easy one now. Let's delete stuff. It works exactly the same. If you have a query like this where you want to delete a specific customer with a specific email, then you can, from your customers database, filter for this specific email. Let's grab this code here. This will be an arrow, but if you throw in a second equal sign, then you see that you get this row here. So we could save this as table, remove customers. Let's save this, and then we can take our customers and then pass it to rows delete, where we use our second table here. And then once again we will get error messages, so we'll have to say, okay, unmatched is set to ignore. And then we see that in this result, Alice Johnson with the email alice@example isn't present anymore, only Alice2s and Alice3s are there. But of course, if we look into the original database connection table again, we see that Alice is still there, and that's because I haven't set the in place argument of rows delete. If I were to use in place and set it to true, then we'd actually delete things in this customers table, but I don't want to do that here. Actually, I don't know why I wouldn't want to do that here. Let me just show you that this actually works. And now if we execute this, we see now that alice@example.com isn't present in the dataset anymore. Now, if you've worked with SQL before, then you might wonder, what about subqueries? Is that a thing we can also do? And for that, I've brought you SQL query that is using a SQL subquery, a very simple one, but it's still a subquery. And the answer to can dbplyr do that? The answer to that is maybe. Honestly, if I see this kind of subquery, I don't bother translating this into a subquery kind of code. dbplyr has some functions like plyr collapse, but honestly, the effort of figuring this out isn't worth it. I would just calculate the mean book prices by summarizing the books table using the mean function and then collecting the result and pulling it so that we have a regular number here. And then I just select the corresponding columns of my books table using the filter function and the variable that I calculated in between. And then I also have my result. This is what I do, but feel free to let me know in the comments if you know of a very elegant way to create subqueries. The examples that I have seen that went into that direction were always kind of messy. So personally, I prefer to just split things up to keep things simpler. And then to keep things really simple, to round things off, let me just show you that you can also only grab a couple of rows by using the regular head and tail function that you normally would. For example, if you want to get only the first two rows, you can use the head function with number 2, and then you'll get only the first two rows that the database table can find. Fantastic. I hope with that you have a new set of skills that allow you to work with databases smoothly. Feel free to let me know in the comments what you think about dbplyr and whether you're still in camp raw SQL or rather using dbplyr instead. Also, if you want to check out some of my other videos, feel free to check out this playlist here where I show you all kinds of other cool stuff that you can do with R. And now, with all of that said, I say thank you for watching and I will see you next time.